Okay, so I thought it would be helpful to go through the exit ticket for weak acids and bases here and see if this would help you. So we're given this problem, we're given this acid-base equilibrium. I realize this is going to be an acid-base one. It has that H3O plus. So this is going to be probably a weak acid problem. I also know it's a weak acid problem because it's HBRO. There are only 7 strong acids. Any other acid is considered weak. So weak acid problems, we are going to have to use a Ka and be really careful with the ice charts. So here they're telling us we have a concentration of HBRO and BRO minus. So I'm just going to go ahead and write the Ka statement here. We have H3O plus times BRO minus all over HBRO. And if you recall, when we do the normal ice charts for these, I did an ice chart. We don't include that water. I'm just going to shorten this up. This would be your concentration here. And then we have nothing here, and then we gain X, we lose X. So what I wanted you to remember is that these two concentrations are equal. So because they gave us a concentration of BRO minus, we actually know the concentration of H plus. So it'll be 3.5 times 10 to the negative 5 times 3.5 times 10 to the negative 5, all over that initial concentration of 0.50. So if we solve this out, this will actually give us our Ka value. So this is an example of how we would calculate it ourselves rather than looking it up in a chart. So I found my Ka to be equal to 2.45 times 10 to the negative 9. Okay, so now it's wanting me to find the Kb. Okay, so if we find the Kb value, Ka times Kb is equal to 1 times 10 to the negative 14. I really want you to know this one really well. We know Ka was 2.45 times 10 to the negative 9, and we're going to solve for that Kb. So 1e negative 14 divided by that second answer, I found Kb to be like 4.1-ish times 10 to the negative 6. Then it says to go ahead and calculate the pH of the solution. And so we have to look back at what those values were. So to do that, we just need to know what our H plus concentration is at the end of all of this. Okay. And so if I solve out my ice chart, I realize that X is going to be the same thing as H plus. Okay, well, my X actually is the 3.5 times 10 to the negative 5. So because if I did 0.5 minus X, 0 plus X, 0 plus X, this is what X is, which is your H plus concentration. So that's the value you're going to be taking the negative log of, which I already forgot what that value was. 3.5 times 10 to the negative 5. So if I take the negative log of that value, I found it to be 4.46, which should be the correct answer. So then they have another problem here. The Ka for acetic acid is 1.8 times 10 to the negative 5. What is the pH of a solution containing 0.72 molar sodium acetate? Okay, and then I gave you this hint that it's a Kb problem. A lot of times we'll be given the Ka, but they're actually wanting you to find a Kb. So the minute you're given a salt, okay, so this is sodium acetate in water. It's going to protonate and it's going to make that H plus and the acetate ion. Since this is a Kb problem, I would go ahead and automatically, using my Ka times Kb equals 1 times 10 to the negative 14, and figure out what my Kb is. So 1e negative 14 divided by 1.8 e negative 5. Helps if I don't typo. I found that to be 5.56 times 10 to the negative 10. And I like to do that right at the beginning so my brain realizes that it is actually a going to be a KB problem. I just realized this should be, I wrote my statement wrong. This is OH minus and this is HC2H3O2. Okay, apparently my brain is not all there either. So just a reminder, water is a HO, so H bonds to that acetate ion to make this, and then that. So that's really what that statement should be. So my bad, I'm sorry. Okay, so what are we given? 0.72 molar of this guy. We don't know anything of this initially. We lose X, gain X. We don't count water. 0.72 minus X, X, X. We're going to write our KB. OH minus divided by HC2H3O2 divided by C2H3O2 minus. We know this is 0.72. I'm going to assume that that X is super small. And then this is X, and that whole thing is equal to 5.56 times 10 to the negative 10. Okay. So, given this information, I can go up here. I can solve for the OH minus concentration. So I'm taking my KB times that 0.72, take the square root. So I find X, which is equal to the hydroxide, which is equal to 2.0 times 10 to the negative 5 molar. If I take a negative log of that, that would give me the POH. So the POH would be a 4.7. And then you could solve for the pH is 14 minus that number is 9.3. So that is how you would do that kind of KB problem. That's very typical of what you'll see in the AP world.